So our test tomorrow is on 3.5, 3.6, and 4.1, just the first part. So we're going to review 3.5 and 3.6. Those two sections were on our quiz, so it would be good practice to review the quiz. We're also going to practice now too. So for 5 and 6, we use the graph to help us find our answer. It's wherever the 2 points, wherever the two graphs intersect. So it'd be at those 2 points. So for number 5, it doesn't intersect at whole numbers, but we can kind of estimate where the points are. So it's a little bit less than 1/2. We could say 1/3, 0. And then the other one would be about like 3 2/3. It's a little bit past halfway of 3. If you said like 3.6, that's fine also, something like that. So you can estimate for this one. So these would be the two answers. What would be our two solutions for number 6? -2, +2. And 0, 6. Perfect. So just find the coordinates for each point. Sometimes our graph may overlap in only one spot, so we would only have one answer. What do you think our solution would be if the two graphs don't overlap? No solution. Perfect. Let's look at number 7. So here we have to solve using substitution. So if we're using substitution, I either need an x equals or y equals. Do I have that here? Yep, we have a y equals. So I would take that and plug it into the y. So here, y is equal to, I'm just going to plug it in, so I would have x squared, because y is equal to x squared minus 3. Then plus 1 is equal to negative x squared. So I just substituted the first equation into the y in the second. And then from here, we can solve. What would I need to do to solve? Combine like terms. So I can add x squared to move it to the other side. What's x squared plus x squared? 2x squared. I can add these two together. So -3 plus 1 would be -2. And that's equal to 0. So here I just have an x squared. So I want to get that all by itself to solve. So I can add 2 to move that to the other side first. So 2x squared is equal to 2. And then what should I do? Divide by 2. So x squared is equal to 1. How would I solve for just x? Square root both sides. What do I have to remember to include in my answer when I take the square root of both sides? Awesome. Plus or minus. And what's the square root of 1? 1. So I have two different answers here. I have x is equal to +1 and x is equal to -1. Now how can I find the y's? Just plug in both x and plug it into the original equation here. So I have y is equal to 1 squared minus 3. So y is equal to 1 minus 3, which is -2. How would I write my answer?
1, -2.
Perfect. 1, -2, your x, and then your y. We do the same thing with the other x. We're going to plug that into x. So I have y is equal to -1 squared minus 3. What's -1 squared? 1. And 1 minus 3 is -2. So here my answer would be -1, -2. So these are my two solutions. So if I'm going to solve with substitution, remember I either need x equals or y equals. Do I have one of those here?
No.
Can I make one of my equations?
Yes.
How? We can do the bottom one.
Add y.
Perfect. We're going to add y to both sides, so that way it'll be y equals. So I have 3x squared minus 16x plus 13 is equal to y. So if y equals this, I'm just going to take it and substitute it into the y in the other equation. So 3x squared minus 16x plus 13. And then the rest of the first equation is minus 12x plus 15 is equal to 3x squared. So now from here, we're going to solve for x. What can I do first to solve for x? I can subtract the 3x squared to move it to the other side. For these questions, you're probably going to have to factor, so you always want it to be equal to 0. So when we combine our like terms, move everything to one side. So it ends up canceling out. What can I do next? So combine my like terms. I'm going to combine the x's. This would be negative 28x. And then the 13 plus 15 would be plus 28 is equal to 0. Now if I only have one x, do I have to factor? No, we're just going to solve for x. So we want to get that all by itself. So what can I do to solve for x? Subtract 28. So negative 28x is equal to negative 28. What would I do next? Divide by negative 28. So x is equal to 1. So x is 1. Am I done? I need to plug it back in to find y. I could either plug it into one of the first two original equations or my new second one, because these two are the same thing. So I'm going to plug it into the new second one just because I think that one would be easier. So I'm plugging it into the x's. So here I have 3 times 1 squared minus 16 times 1 plus 13 is equal to y. Make sure you follow your order of operations. 1 squared is 1, and 1 times 3 is 3. Minus 16 plus 13 is equal to y. Here we would have 3 minus 16, which is negative 13, plus 13 would be 0. How would I write my answer? 1 comma 0. So here we only have one solution. It's fine to only have one answer. Don't be concerned if you only get one solution. It's fine. We could have 2 answers, we could have 1, we could have none. All right. Let's do 11. So here we're going to solve with elimination. So when we solve with elimination, you want one of your variables to cancel. Either all the x's have to cancel, or you need to get the y's to cancel. So in order for something to cancel, they have to have the same coefficient, but opposites. One has to be negative, one has to be positive. So for 11, what do we want to cancel? Well, if I get the 3x's to cancel, the x squared also has to cancel with something. Is the x squared going to cancel with something in a second?
So you need to make one of the y's positive.
Perfect. So I have to get the y's to cancel, so I need to make one of them positive. So I can multiply my second equation by just negative 1. So if you do that, you have to change the signs of everything in that equation. Now we can combine like terms. X squared doesn't have anything to combine with, so that's just x squared. Then here I have negative 3x minus 3x would be what? Negative 6x. Negative y plus y cancels, which was our goal. We needed the y's to cancel. And then negative 6 minus 5 would be negative 11. What would I need to do next to solve? Perfect. I need it to be equal to 0 because I'm going to have to factor. So I got to add 11 to both sides. Do I have any like terms that can combine with? Nope. So I'm going to put it in standard form and see if it factors. Do I have 2 factors of 11 that add to negative 6? No. So what do you think my answer is? No solution. If it does not factor, your answer is no solution. You could plug it into the quadratic and see that you would have an imaginary solution, but then it's still no solution. So if it doesn't factor, your answer is no solution. All right, let's do 13. So 13, can I get one of my variables to cancel right off the bat? No, but what can I do to make either the x's or y's cancel? I can multiply by a negative to get which one to cancel? Do we want the x's or y's to cancel here? Why? Because we can't get the x squared and the x to cancel at the same time because there's two of them. It wouldn't work. So we need the y's to cancel. So I'm going to multiply one of my equations by -1 to change all the signs. That way my y's will cancel. So I have -y plus y would be what? Just cancel. So it's just 0. Then I combine my x squareds together. So 2x squared plus 3x squared would be 5x squared. 18x plus 12x is 30x. And 16 plus 24 would be 40. So it's already equal to 0, so I can go ahead and factor. How would I factor this? What's the first thing I should do? Before we multiply the first, we want to take out the GCF. So always see if you have a GCF to take out first. It'll make factoring so much easier. So I'm going to divide everything by 5. When the GCF is just a number, it goes away. If your GCF was an x, you would have to make sure you leave it in your question, and then, like, once you factor it, you leave it outside. But here, since it's just a number, it goes away. So I have 0 is equal to x squared plus 6x plus 8. I just divided everything by 5. Now we can factor normally. It makes factoring a whole lot easier when we take out the GCF. The numbers are a lot smaller. Do I have two factors of 8 that add to 6? 2 and 4, 4 and 2. So x plus 4 and x plus 2 equals 0. What would I do next to solve? Set them both equal to 0 and just flip the signs. So x plus 2 equals 0, x plus 4. So what does x equal? -4 and -2. How can I find the y's? Plug it in to all the x's. So I have y is equal to 3 times -4 squared plus 12 times -4 plus 24. I plugged it into the second equation, but you can plug it into the first one if you wanted to. You should get the same thing if you do the math right. So y is equal to, make sure you follow your order of operations. I have to square the -4 first. So that would be 16. And what's 16 times 3? Positive 48. Because it's -4 squared, which is positive 16, times positive 3. So positive 48. Plus 12 times -4 would be what? Minus 48. Plus 24. 48 minus 48 cancels. So y is equal to 24. How would I write my answer? -4, comma 24. Perfect. We do the second thing with -2 also. We do the same thing with the second number. So y is equal to 3 times -2 squared plus 12 times -2 plus 24. Just follow your order of operations. So -2 squared is 4. 4 times 3 would be 12. 12 times negative 2 would be negative 24, and then plus 24. So negative 24 plus 24 is just 0. So y is equal to 12. What would my final answer here be? Negative 2 comma 12. Awesome. So these are my two solutions. So this question said solve using elimination, so that's why we used elimination. But could I have used substitution here? Yeah. I had y is equal to this, and I could have just taken it and plugged it in, and you would have gotten the same answer. It's almost even like the same work, too. On the test, there's two questions like these, and the directions for both of them just say solve using substitution or elimination, so you can pick. So for 3.6, there's our graphing inequalities. So just as a reminder, if it is greater than or equal to or less than or equal to, does that get a solid parabola or dotted parabola? Solid. So it's either a solid upwards parabola or solid downwards parabola. It could be either one. What if it was just greater than or just less than? Then it'd be dotted. So dotted parabola, it could either go up or down. What tells me if my parabola goes up or down? If A is negative, then it goes down. So if A is less than 0, meaning that it's negative, then our parabola would go down. So from the first part, I want to graph number 3, since it's in vertex form. So 3 is in vertex form, so I can clearly identify my vertex without doing any math. What would my vertex be here? What would the vertex be? Negative 1 comma 2. Remember, you always flip the sign of h. So you always flip the sign of the first one. So we can go ahead and graph that point. I'm going to go to the left to negative 1 and up 2. Now without even finding another point, how could we find another point? Plugging in a number. We could always just plug in a number to find another point, but without even plugging in a number to find another point, do I know if my graph is going to open up or down here? Down. How did we know? Because A is negative. The number out front is negative, so we know that it's going to open down. So my graph would look like this. Now, how can I figure out where I'm going to shade? I can pick a number inside my parabola. What's a number I could plug in? 0, 0 is inside, that works. So I'm going to plug in 0 for x and 0 for y. So 0 is less than negative 0 plus 1 squared plus 2. So 0 is less than, this would be 1 squared, which is 1, times the negative on the outside, so negative 1 plus 2. So 0 is less than 1. Is this true? Yes. So since this is true, where am I going to shade? Inside. So that is my graph.
So we didn't have to put another.
All right, let's look at number 7. So here we have two inequalities. So I'm going to start with the first one. What would my vertex be for the first inequality here? 0, 0. Awesome. We could use negative b over 2a, but what's my b here? 0. And then when we plug in 0, we still get 0. So I'm going to graph that point. My vertex is at 0, 0. Is my parabola going to open up or down? Up, because a is positive. So we know it opens up. And is it solid or dotted? Dotted. So my parabola looks like this. And now let's figure out where we're going to shade. What point can I pick to test where we shade here? Perfect, 0, 1, that's inside. So I'm going to plug in 0 for x and 1 for y. So I have 1 is greater than 0 squared. Is 1 greater than 0? Yes. So where do I shade? Inside. If it's not true, you would shade outside. Yes. So let's graph our second inequality here. How do I know where my vertex is going to be for this one? Negative b over 2a. So this is my a, b, and c. So negative 2 over 2 times 1 would be negative 2 over 2. So negative 1. Just be careful with your signs here. So the first number of my vertex is negative 1. How do I find the second number? Plug it in. So I have negative 1 squared plus 2 times negative 1 minus 4. So 1 minus 2 minus 4, which would be negative 5. So on my graph, I'm going to go to the left negative 1 and down 5. How can I tell where my second point is going to be? How do I know where another point on my graph is going to be? I could plug in another number, or I could use the y-intercept. So my y-intercept is negative 4, so I cross the y-axis at negative 4. But without even doing that, do I know if my graph is going to open up or down? Up, because A is positive. So I know my graph is going to open up. Is it a solid parabola or dotted? Dotted. So my parabola will look like this. I'm going to make sure I extend my lines so they overlap. It overlaps just a little bit over here. And now let's figure out where we shade. How do I know where I'm going to shade? What can I test? I can test 0, 0. So I have 0 is less than 0 squared plus 2 times 0 minus 4. So 0 is less than negative 4. Is this true? No. So where do I shade? The outside. So shade the outside. So remember, our answer is where the graph overlaps. So you can point an arrow to it. So the overlap is the solution. This one just barely overlaps. I actually graphed it in the last class, and the way I drew my lines, it looked like it didn't overlap at all. And I was like, oh, it doesn't overlap, no solution. But I looked it up on a graphing calculator, and there's just a little tiny sliver of overlap. So that whatever overlaps is our answer. On the test, it'll be a little bit more defined. You'll see it. It'll be clear. It'll overlap for sure. All right, there are no number line questions on the test, so we're going to skip those just to make sure we have more time. So the first 9 questions here were actually the same ones that you guys had to do on your homework. So I'm going to go down to like the bottom part. So looking at number 1 on the bottom half. So we have to decide whether the function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. So for number 1 on the bottom half of the page, is this a polynomial? No. Why not? Because it has a negative exponent. So this is not a polynomial. So the things that make it not a polynomial is if we had a negative exponent, so like x to the power of negative 2. If x was in the bottom of a fraction, if x is in the exponent, so let's say I had like 2 to the power of x, or if x was inside a square root. A number can be inside a square root, a number can be in a fraction, but x cannot be. So these are the 4 main cases where it would not be a polynomial. Let's take a look at number 3. Is 3 a polynomial?
Yes.
Yes. So how would I put it in standard form?
2x to the fourth power.
Perfect. We start with the highest degree, so that would be 2x to the 4th power. What would come next? Minus square root 14x cubed. And then? Minus 1/3 x squared. And then? So plus 2x minus 5/3. Awesome. So we start with our highest degree and then just go down from there. How would I classify this by degree? The highest degree is 4, so what do I call something with the highest degree of 4? Quartic. Think like 4 quarters, but quartic. How many, so to classify it by terms, how many terms do I have here? 5. So what do I call something with 5 terms? Polynomial of 5 terms. Or you could just say polynomial of 5. That's fine too. And then what is my leading coefficient? 2. So make sure you know the list of words that classify as degree and classify as the number of terms from the notes. So if you don't remember those, go back and look at the chart in the notes.
C is the highest number.
The leading coefficient is the number in front of the highest degree one. So once you put it in standard form, it'll always be the first number there. Yeah, I'll do a few of those. I'm going to finish this section though, just for more practice. For number 2, is this a polynomial? Yes, what would come first? 11x squared. Then we have plus 12x minus square root 7. How would I classify this by degree? So my highest degree is 2. What do I call something with the highest degree of 2? Quadratic. How many terms do I have? What do I call something with 3 terms? Trinomial. And then what is my leading coefficient? 11. It's the number in front of the highest degree term. So my leading coefficient is 11. Is 4 a polynomial? No. Why not? There's an x in the bottom of a fraction. So not a polynomial. All right, let's look at the bottom part. So here we're going to describe the end behavior of the graph. So we always have to look at our highest degree term, and that'll tell us. So which term do we look at for number 8? Negative 7x to the 6th power. Everything else does not matter. We are only looking at that one term. Now remember, positive or negative tells us what the right arrow does. So is this positive or negative? Negative. So what's our right arrow going to do? Falls right. It goes down because it's negative, so we would say falls right. So we always start with the right arrow. Now is our degree even or odd? Even. So do they go in the same direction or opposite? Same direction. So if we fall right, what's the left one going to do? Same direction. So it's going to fall left also. Because we did the right one first. If it falls right and they go in the same direction, the left one's also going to fall. If it's positive or negative, always tells you the right one. The right one first. So always start with the right one, then figure out if it goes left or if it goes up the same direction or opposite directions. All right, for number 9, which term am I going to look at here? 4x to the 5th power. Be careful because on the test, they may not be in standard form like these. Right, so like these, they're not in standard form. So don't always look at the first one. Your highest degree may not always be the first one. So what's my right arrow going to do here?
It's gonna rise.
So the right arrow goes up because it's positive. So it rises right. Perfect. 5 is odd. So that means they go in opposite direction. So what's the left one going to do? Falls left. All right, last type of question that you'll see on the test are the evaluating ones. So like number 5 through 7. How would I evaluate the function? What would I need to do? Plug it in. So it'll give you a number for x. We're going to take that number, plug it into our x's, and solve. How would I write my answer? Your answer is going to be a number, but how do I write it? So we plugged in -1 for x. So I would say f of -1 is equal to whatever your answer is. Just like this. Don't forget this f of -1. For the second one, we would say f of -6 because that was our x that we plugged in. Or g of. This one's a g, but same thing. So you just have to write this as your answer. And then whatever number you get when you plug it in and solve.
You have to plug that one in every single one of them.
No. There'll be smaller numbers like 1, 2, or 3 to plug in.